Okay, hi everyone. This is lesson 6.4, and we're continuing where we left off in lesson 6.3 with adding and subtracting. And this time we're going to have denominators that have more than one term. But the idea is going to be the same. We want to create a common denominator and then add those fractions or subtract the fractions together. Okay, let's do the construct your understanding. I'm going to do this one. So when we are doing adding, subtracting rational expressions with more than one term in the denominator, what you want to do is first factor the denominators. Okay, so this first one can be factored to x plus 3 and x plus 3. The second one is already factored. It's just a binomial there. Okay, and you can put it in brackets if you want. It doesn't have to be, but then you can kind of recognize that the first fraction has x plus 3 times x plus 3. It has two terms that are multiplied together. They're both x plus 3. And the second one just has one, x plus 3. So we want to make those identical. We want to make them the same. So let's multiply the second fraction, top and bottom, by x plus 3. That way, the denominators in both fractions will be identical. When we do that, we have to remember if you're multiplying by more than one term, we have to multiply the two to both terms there. So let's see what we've got then. Before we keep going too, we should write our non-permissible values. In this one, all the factors are the same and they all are x plus 3. So the non-permissible value here for x would be x cannot equal -3, because that would make each one of those terms 0. Okay, so let's see what we've got. The first fraction stays the same. X plus 3, x plus 3. In the second fraction, expanding that 2 in, you would have 2x plus 6, x plus 3, x plus 3. Okay, so now we see that the denominators are identical. And so we are free to add and subtract, or in this case, subtract the numerators from each other. What we have to do is find the like terms. So we are subtracting here. We have to be really careful of the sign. I have no x terms in the first fraction, but I do have an x term in the second fraction. So I have -2x. -2x. Because it's like essentially like saying 0 minus 2x. It would be -2x. And then the like terms here are 3 and 6. So 3 minus 6 would be -3. And x plus 3, x plus 3, and we've got our non-permissible value. X cannot be -3. So that's the main idea. Create a common denominator, add the numerators together. We're just going to be doing some more examples, but this lesson is not too long because that's the key idea here. So let's go ahead and try check your understanding number 1. If you actually want to try this on your own, you can. I'm just going to do 1A, and if you want to go ahead and do 1B, you can as well. Okay, so let's look at 1A together. I'm just going to rewrite it here, p minus 1, or p minus 2. I like to put the denominators just in brackets so I can recognize them as actual factors. And then p plus 3 over p plus 1. Okay, so the denominators are totally different. So that means that we're going to have to multiply by the other one to make them identical. So the second fraction here, I'm going to multiply the top and the bottom by p minus 2. Okay, I'm going to put brackets around this as well to remind myself I'm going to have to FOIL there. And then the first one, I'm going to multiply by p plus 1. That way, both denominators will have a p plus 1 factor and a p minus 2 factor. And when I multiply the numerators, I'm going to have to expand. Okay, let's write our non-permissible values as well before we get too far ahead of ourselves. There's two factors in the denominator, so one non-permissible value would be 2, and the other one would be -1. Okay, let's go ahead and write what we have now. So both denominators are going to be the same. They're both going to be p plus 1, p minus 2, and p plus 1, p minus 2. The numerators, we're going to expand them out so that we can collect like terms when we add. So we do have to FOIL. So p times p would have p squared. The middle two terms would cancel out here. We've got a difference of squares. So we'd have p squared minus 1. And then for this one, I'd have p squared minus 2p plus 3p, so plus 1p, oops, and then minus 6. Okay, now we're ready to add our fractions together. Our denominators are identical, so we can go ahead and add the numerators, and I'm only going to add the like terms together. When we're adding and subtracting, we can only add like terms. So p squared plus p squared, that's going to give me 2p squared. I don't have a second p term, so I'll just have plus p. And then I'll have minus 1 plus negative 6, so minus 7, all over p plus 1, p minus 2. And that is it. And I can rewrite my non-permissible values here, my final answer. Okay, so you guys can try B if you like, or you can move ahead to a little bit more of a challenging example. Check your understanding number 2. Okay. So in the first example, we didn't need to do any factoring, but this one has some trinomials here. So we will have to factor first before we can make a common denominator. And also it helps us determine what our non-permissible values are as well. So let's go ahead and factor before we do this. I'm going to do A, and then you guys can try B on your own. Actually, yeah, okay. Let's actually, you know what, we're going to do B, because subtracting can be a little bit more challenging. So we'll do B, and then you guys can try A on your own. So let's do B. So we're going to factor first. The first one factors to n plus 6, n minus 3. And over here, I've got n plus 5, n minus 4. Okay, let's write our non-permissible values before we get too far ahead. There's actually going to be 4 of them because there's 4 factors in the denominators. I'll have negative 6, 3, negative 5, and 4. Okay, so now what we want to do here is make our life as easy as possible. In this first fraction, you might notice that there is an n minus 3 factor in both the numerator and the denominator. We can go ahead and cancel that out, and so we don't have to do too much work when we're making a common denominator. Okay, so in the denominators now, I've got 3 different fractions or factors. They're all different. So to make them identical, I'm just going to have to multiply by what's missing. So over here, I'll multiply it by n plus 6. And over here, let's see if I can fit this in, n plus 5, n minus 4, in both the numerator and the denominator. Okay. I'll put brackets around my top factor there just to remind myself I will have to FOIL that out. Okay, let's write what we've got now. So both fractions will have identical denominators. They'll have n plus 5, n minus 4, and n plus 6. Same with the second one, n plus 5, n minus 4, and n plus 6. Okay. And in order to collect like terms when I'm subtracting these, I will have to FOIL out these terms here. So let's FOIL these out. So this will be n squared minus n minus 20. And this one will be n squared plus 6 minus 2. So that'll be plus 4n minus 12. Okay, let's go ahead and collect like terms now. And this one is, we do have to pay attention. We are subtracting, so we will have to pay attention to signs a little bit more closely than we do when we're adding. Okay, let's do the n squareds first. We have n squared minus n squared. That's going to be 0. Then we have negative 1n minus 4n. So that'll be negative 5n. And then for the last one, I'll have negative 20 minus negative 12. Subtracting and negative is like adding. So that will be like negative 8. And then all over the same denominator, n minus 4, n plus 6. The denominators were identical. You have to make sure of that before you can add or subtract. And I believe I'm done. I'm just going to double check the answer. I did make a mistake here. Okay, when I FOIL this out, this is why we do this. When I FOILed this out, I did FOIL this out wrong. This should be plus n. Yes. So then when I subtract, I should actually only have 3n. So you should always check your answers. It's easy to make a small error. Everything else looks good though. And I'm going to rewrite my non-permissible values. Just go ahead and pause if you want. I'm going to highlight that mistake I made. So I had negative n here. It should have been plus n. And then I had -5 here. It should be -3. Okay, there we go. And that's actually it for the lesson. There is one more question where they have an application, but we're going to focus on the applications at the end of the unit. And so we're not going to do that one today.